Hello everyone, here are some tips for 3D printing architectural models with the FDM printer. For this tutorial I will be using the slicer Cura, which is a program you can download from the Ultimaker website for free. So let's begin. Avoid overhangs. Let's say you want to print a model that shows construction features like slabs, trusses, columns and so on, like in this example. When printing with a FDM printer, short for Fused Deposition Modeling, you have to take on account that extra support geometry will be required to build these overhangs, thus increasing the printing time. And besides that, this extra geometry has to be carefully removed, usually leaving traces at the bottom side of the overhang surfaces, which is not optimal. So the best approach for this kind of models is to split them into pieces. Place them and orient them so that the bottom surfaces are touching the base plate of the printers, and with this avoiding as much as possible overhangs. If you have more than one printer, then you can organize the printing jobs so that they happen simultaneously, and with this reducing the printing time of the whole. Exporting. Before exporting your geometries from Rhino, I advise you to create a new file from the original, but with units in millimeters, and scale down your models to the size of the printing model. In this case, the model will be printed in 1:100, so 10 mm is to 1 meter. Then for exporting, use the STL or OBJ format. STL format, or Standard Tessellation Language, is the default format for 3D printing. It is lightweight and universally supported, but it only contains surface geometry, no color and no materials. If you use it, you should lower the tolerance value to get a more precise approximation of the resulting mesh. Otherwise, you may get some undesired facettings on the surfaces, especially if these are curves, like in here. You can also adjust some other detail settings by opening the Detail Control button, and when exporting, pick the binary file type, which is smaller than the ASCII type. OBJ, or object file, on the other hand, is better for complex color or multi-material prints. It handles polygons beyond triangles, and it can store color and texture data, which often requires a companion MTL file. And in the same way, you can adjust the NURBS meshing parameters or the sub-D meshing parameters to get a better approximation of the resulting mesh. In short, more polygons, better the results. It's important to place the pieces near to each other, either before exporting to the slicer program, in this case Cura, or inside Cura. This reduces the trajectories that the extruder has to travel during the printing process. And by orienting the pieces so that the geometries match the X and Y axis of the printer, if possible, then you decrease the complexity of the movements, which also reduces the printing time. This can also get done by picking the auto orientation from the extensions menu. You can select Calculate Fast Optimal Printing Orientation or the Calculate Extended Optimal Printing Orientation. Again, 3D printing is a slow process, but by choosing the gyroid infill you can save some time. Because of its minimal surface structure, it provides sufficient stability with continuous surfaces, making it relatively faster than other infill types. I'll show you here. First, with the grid and 10% infill, it takes 7 hours 1 minute to print. And now with the gyroid and 10% infill, then it takes 7 hours 2 minutes, almost the same time. But we see here that it's too dense, so the infill can be reduced to 5, or better, let's leave it at 6%, and now we have 6 hours 33 minutes. You see, much less time. These two values are directly proportional. That means that if the nozzle gets hotter, you can increase the velocity of the printing. Nevertheless, I would suggest never to print over 210 Celsius with PLA, so you avoid getting toxic fumes. And I also suggest you to choose the velocity according to the quality you want to achieve. If you want high quality, then you should lower the velocity, and for lower quality, increasing the velocity. But it may happen that the extrusion velocity of the filament doesn't follow, so you end up with bad results. A good speed for 3D printing with PLA would be around 50 to 80 mm per second. Tap Anti-Warping and Spoon Anti-Warping are two great plugins for Cura. You can find them and install them from the marketplace, and it's very easy. These both allow you to add tabs or spoons in areas where the geometries could warp. Warping means when the geometries get deformed by not sticking to the base. But with these spoons or tabs, this can be avoided because these bring more touch surface to the base. In this example, the geometries are very thin, so it may happen that they warp if I don't use the brim. But instead, I can use the tabs or the spoons and either place them in auto mode or manually to achieve better adhesion to the base plate. Now, to finish, here are some useful functionalities from Cura, like the mirror tool that works by defining the mirror orientation, like here, or the support blocker, which helps you to generate boxes that will block the construction of the support. You just make a box like this. And to make copies, right-click with the mouse and select multiple selected, then input the number of copies, and this will be generated and placed in an optimized position. That's it for today. As you see, 3D printing models, it's not just exporting and press one button to get things happen. You really have to get into it. You have to learn how to adjust the parameters, how to prepare your files in order to get good results. And this takes time. Well, all good things take time. If you found this tutorial useful, be kind to like it, share it, and subscribe if you wanna see more. Take care. Ciao, ciao.